Acceleration and velocity. The acceleration is the increase in rate or speed of something. Velocity is the speed of something in a given direction. The acceleration is the second derivative, and the velocity is the first derivative. Since velocity is the first derivative of a given function, let's start with finding the velocity. Example 1. The position equation for a moving particle is given. S of t equals negative 40x over 2 minus 12x plus 28. Where S of t is measured in feet and t is measured in minutes, find the velocity when t equals 3 minutes. Step 1 in finding the velocity is to find the derivative. So the function is S of t equals negative 40x squared over 2 minus 12x plus 28. So we use what we already know about finding derivatives to recognize that the 28 is a constant, and so the derivative is 0, which is why it disappears. The negative 12x, you would multiply the 1 times the negative 12 to get rid of the x, which is how you get negative 12. And then you multiply the 2 in front of the negative 40x, which would give you negative 80x. However, it's divided by 2, so you get negative 40x. So the derivative is s prime of t equals negative 40x minus 12. Step 2 is to plug in your given value of 3 for t into the first derivative we just found. So the derivative is s prime of t equals negative 40x minus 12. That x should be a t. My apologies. So you get negative 120 minus 12. So you get negative 132 after plugging in the 3 for t. So the velocity is negative 132 feet per minute. So next is acceleration. Acceleration is the second derivative. So the only way to find it is by finding the first derivative first. So this example is, a particle moves along the x-axis. The function s of t gives the particle position at any time t greater than or equal to 0. The function is s of t equals 2t to the fourth minus 3t squared minus 4t plus 2. Find the acceleration of the particle at t equals 2. Step 1. Find the velocity, which is, as we have learned, the first derivative. So you have the function s of t equals 2t to the fourth minus 3t squared minus 4t plus 2. So applying the same rules in finding derivatives, you bring down the 4 times the 2, so you get 8t to the third. Bring the 2 down to the 3, negative 6t. And then you have negative 4t, so you have the 1, the t being raised to 1, times negative 4, making that variable negative 4. The 2 is a constant, so the derivative of a constant is 0, which is why it disappears. Step 2 is finding the second derivative, which is where we can apply our knowledge to find the acceleration. So finding the second derivative, you take the first derivative and apply the same rules. Bring the 3 down to the 8, you get 24t squared. The t being raised to the 1 times negative 6, you get negative 6. Then you have negative 4, which is a constant, so once again, the derivative of a constant is 0. So the second derivative is s prime of 2t equals 24t squared minus 6. Then, for our final step, is to plug 2 into the second derivative. S prime of t equals 24t squared minus 6, like I said. So plug in 2 for t. 24 times 2 squared minus 6. Now our work is basically done, but to sum things up and to simplify, you have the second derivative when the particle is t equals 2. So you have 24 times 4 minus 6, which is 96 minus 6, which is 90. And then the units are meters per second squared, because you had to take notice, as written down below, that the acceleration is dividing the change in the velocity by the time it takes the change to occur. So the units are meters per second squared. Now let's move along. Combining what we know, at time t, a unit is moving along a line at s of t equals t cubed minus 12t squared plus 36t plus 14. Find the unit's acceleration each time the velocity is 0 meters per second. So once again, you have step 1, which is find the first derivative. So you have s of t equals t to the third minus 12t squared plus 36t plus 14. So to find the first derivative, you apply the power rule, bring the 3 to the front, 3t squared. Bring the 2 in front of the 12, negative 24t, and then you have 36t, bring the 1 with the 36, so you get 36. 14 is a constant, so you have 0, so it disappears. Step 2 is set the velocity equal to 0, so you have that first derivative, which is the velocity. You set it equal to 0, so you have 3t squared minus 24t plus 36 equals 0. Divide the 3 out, so you get t squared minus 8t plus 12. Then you factor, so you have t minus 6 times t minus 2. General factoring rules apply. Equals 0. Set each term equal to 0, so you have t equals 6 and t equals 2. So all that to be said is when you're finding velocity, when you have 6 in the original equation, it's going to equal 0, and then when you have 2 in the original equation, it's going to equal 0 as well. So those are your two terms where the velocity equals 0, which is the second part of the problem. Step 3 is finding the acceleration when the velocity is 0. So we do this by finding the second derivative, because that's going to give us the acceleration. So you have s prime of t equals 3t squared minus 24t plus 36. So you apply the same rules. You bring the 2 down to the 3, so you get 6t minus 24, which is the second derivative, and that is going to help us find the acceleration when the velocity is at 0. Step 4, plug in the variables which we found for step 2 when the velocity equals 0 into the acceleration derivative that we just found in step 3. So your acceleration derivative is 6t minus 24. So you plug in the variables of t equals 6 and t equals 2, because those are where the velocity is equal to 0. So you have 6 times 6 minus 24, 36 minus 24, which is 12 for the variable of 6. Then you plug in the variable of 2, so you get 12 minus 24, which gives you negative 12. So step 5 is basically just a summary. So when you have velocities equal to 0 at 6, the acceleration is going to be 12 meters per second squared. Since it's positive, the acceleration is increasing. And then when you have the velocities equal to 0 at 2, the acceleration is going to be equal to negative 12 meters per second squared. And since it's negative, it's decreasing. The acceleration is decreasing. Okay, so moving on, this one's going to be a little bit harder with trig. Find the velocity and acceleration of a function whose position is s of t equals cosine 2t plus sine t. Step 1, find the velocity, which is the first derivative, as we've been doing this whole time. S of t equals cosine 2t plus sine t. You have to apply the chain rule. So you take the derivative of the outside function, which is cosine. So the derivative is going to be negative sine, times the original, or the inside, which is 2t. But then you also have to multiply that by the inside derivative. So you have the 2 from the 2t. Then for the second term, sine t, you have the derivative of the outside is cosine times the original, which is t, times the original derivative, which is going to be t, so the derivative is just 1, so it's the same function. So then, to keep simplifying, you take the 2 and you multiply it in front by the negative sign to give you negative 2 sine 2t plus cosine t for your velocity derivative. Step 2 is finding the acceleration, which is the second derivative. So you take the first derivative, s prime of t equals negative 2 sine 2t plus cosine t. Find the derivative of that using the chain rule as well. So it's easiest to work from left to right, so you have the negative 2 sine t. The derivative of that is going to be negative 2 cosine, the outside function, times the original, which is the 2t, times the derivative of the inside function of 2t, which is 2. So if you look down at the bottom, that gives you negative 4 cosine 2t. So then you have the right side, which is cosine t. Find the derivative of the outside function of cosine, which is negative sine, times the original, then times the derivative of the inside function, which is t. So once again, it is just 1, therefore making it the same function. So at the bottom, it's going to be minus sine t because of the negative sign. So your acceleration derivative is going to be negative 4 cosine 2t minus sine t. Just a recap, acceleration is the rate of change of velocity over time. And some examples for application is it can be used for roller coaster design, fighter pilots, and a lot of times crash tests for crash injuries. Velocity is the speed of something in a given direction. It can be used for the speed of ships, planes, rockets, and other things. Also, an interesting fact I found was a lot of times velocity is used to calculate the continental plates that are shifting.